Hello and welcome back to Hacktivity Explained, the series where I go over some bugs found by other bug bounty hunters in the hopes that you might learn something from them. And in this video I'm going to be covering two client-side path traversal vulnerabilities, one on Gitlab and one on Acronis. If you haven't heard about client-side path traversal vulnerabilities, then I highly recommend you to go watch my previous episode where I cover exactly this topic. It's a super interesting vulnerability that I think is a bit underexplored right now, so I'd love to make a Hacktivity Explained episode on it to learn a bit from this as well. Without further ado, I'll just first of all go over a quick explanation of what client-side path traversal is, for those of you who are too lazy to watch the video, and then we'll hop straight into the reports. If you already know what it is, then just you can skip with the tabs in the video. So, client-side path traversal is basically when user input is appended unsanitized to the path parameter of a request. So this normally occurs in a JavaScript context where JavaScript will take some kind of input from the path, whether that be just a URL path like this, or a query parameter, or even the fragment parameter, and then place it inside the path for another request, which it will send to usually some kind of API. So in this scenario, once the user clicks on this post, for example, it'll fetch it, and then the JavaScript will notify the API that the user has seen this. So for example, it'll give the video a view or something like that. And an attacker can actually manipulate this in the right context by placing a path traversal payload and then going back to a different API to perform a CSRF type attack. So in this scenario, as you see here, we have this %2f. That's the same as that's the same as the slash. The %2f is the same as /, and // just goes back a directory. So if you type into your file manager, you type in // it'll go back to the previous directory. And this is just the URL encoded question mark. Point is, when the JavaScript goes to place this inside the body of a request, in the path of a request, it'll URL decode it to a //, then it'll go back the path. So in this case, instead of fetching the post, or basically telling the API that post has been seen, it will try to reset the password of the user. In this case, it is seen parameter here. That's obviously not very good. We don't want that to happen. And as an attacker, we can identify these kind of injection points, and then we can take advantage of them to basically perform CSRF. This is good because it bypasses the same site cookie defense mechanism a lot of browsers have brought in. Also, this bypasses like CSRF tokens because when the website is sending a post request, it'll automatically give us the CSRF token. We don't even need to know it. So yeah, we can perform CSRF type attacks. We can also get like cross-site scripting and a number of other attack vectors from this. This great vulnerability type. This is some code that could potentially result in a client-side path traversal if the user path isn't sanitized, so it's not URL encoded or anything, and this resolve function is relied upon by other functions to make their requests, then this will just basically cleanly concatenate these two paths, and then it'll leave in the path traversal payloads. So there's specific functions in JavaScript that basically will concatenate two paths together by and get rid of these path traversal payloads. So one thing you can do is URL encode it, as it depends, because then the request will not see it as a path traversal, it'll just see it as a URL encoded parameter. And something else you can do is just to get rid of the path traversal things, or use specialized functions like in Python. If you're doing like a backend, there's something called path.join, which kind of alleviates these path traversal payloads. So yeah, that's the high level explanation of path traversal. Now let's hop into the first report, which is on GitLab. So our first report is on GitLab. And GitLab is basically just a CI/CD pipeline tool, basically updates like commits from GitLab, which is kind of like a GitHub kind of thing. And in this case, companies can set up their own GitLab instance called GitLab Enterprise, and they can obviously have like administrators and users and stuff like that. So you can also make projects here. Project just represents like one application, and it's for managing the requests and pull requests and Git pipelines and stuff like that. And what you can also do is you can integrate Sentry with GitLab, so your GitLab instance. And Sentry is basically like an error management tool. It'll basically notify you if there's been like mistakes in your code or there's like bugs. It's good for keeping track of mistakes and stuff like that. If you've ever like encountered an error in a website, it'll say like the people have been notified of this. Usually that's through Sentry. They've received the Sentry error, like you see here. So when someone creates a new project, they can actually basically add Sentry into it. They can add like an integration, and this is done through a different API. So you add the Sentry API through a URL, and there was actually the vulnerability here because an attacker could create a new project and add whatever URL they wanted as a Sentry. And this didn't have to be the actual legitimate Sentry server. This could have been an attacker-controlled server that sent whatever API they wanted to. So in this case, what the attacker did is they basically created a Sentry server that responded with a path traversal payload for the ID of the error. So if you could imagine something like this, right, where there was a JSON parameter response and it said like ID is equal to our // payload, and then the title was there as well, and then there was other parameters like maybe make that a little better. There was like a title as well, and that was just like our JSON response, right? So the server just took this ID parameter and placed it inside like the JavaScript here, and it didn't actually validate whether or not that was a valid ID, so whether or not it was numeric or it was actually valid at all. That means that when a user clicked on it, they actually clicked on a path traversal payload. So the website tried to take them to that ID. So for example, it was like /error / the ID of the error, like so. But instead of that, they got taken to like error .. right? And that went back to the directory. So by doing this, the attacker could actually redirect the user into a different directory and make them send a request where they didn't want to send a request to. And in this case, if the victim clicked to like resolve the error, which would basically initiate a put request, the attacker could then use that put request to perform actions on behalf of the user. So a CSRF type attack. In this case, what the attacker did is using this payload right here, they actually made the administrator promote the attacker to an administrator themselves. So that created a privilege escalation type vulnerability here. And this is kind of the highest possible impact you can actually achieve with a client-side path traversal, because it basically makes you an admin, so you can do anything you really want to on the server. So the attack vector would be the attacker creates a project, then they hook up a Sentry link to it, and basically create that kind of path traversal payload in the ID, which makes the GitLab instance display this here. If an administrator or some kind of support user comes in and clicks this button here, the attacker will automatically be promoted to administrator. So presumably the attacker could like convince the support agent to click this button and say like, oh, this isn't working for me, can you try it please? And then the support agent will click it, and then the attacker will be promoted, right? So this was a high priority vulnerability, and I think the reason for that was because the attacker actually had to be a member of the GitLab instance, so it required a little bit of permissions from the attacker. But apart from that, it was a very sound vulnerability, very high impact, and quite easy to do actually. It's actually quite reasonable to assume that someone would just click a button. It's not that crazy to convince someone to click a button on a website, so I think that's actually very reasonable. And the payout for this was about 7,000, I think, which is a very decent payout for GitLab anyway. So there's a number of things you could do with this as well. So make admin, elevate. It's kind of most like CSRF type attack like this, right? And the fix was this actually to validate whether the Sentry ID was actually a number. So it had to now be an alphanumeric number. And then they also sanitized the path. whenever they placed the button inside the HTML. Yeah, so that's it for this report. I think it's very interesting. These integrations often have vulnerabilities actually. It reminds me of that Google Documents one, where the person was able to perform an SSRF vulnerability by exploiting a Google Docs implementation. So definitely worth testing some of these out. Probably something that I won't think of myself, but it's interesting to see how you can exploit a client-side path traversal vulnerability. And with the ID thing as well, actually, one thing I have to mention is that because the way the ID parameter works, the database usually will not allow any kind of path traversal payloads or malicious payloads inside an ID parameter. That's because when the website goes to save that data inside the database, it actually just won't work because the database will error because you see usually some kind of type like a UUID, right? And the UUID will not accept this. So even if the website performed no checks against the ID parameter, you probably would not be able to place a path traversal payload in there normally. Because, however, this was an implementation with a different service, the website didn't need to store the ID inside the database. It simply took it from the API. That's why this attack was actually possible with the ID. Where usually these ID parameters are quite hard to exploit because of how the database behind the website works. So yeah, I think that's everything for this type of vulnerability. And I just want to say before we go on that I actually have bug bounty labs in the description of the video. They concentrate on server-side attacks, so not this stuff actually, but kind of more like SSRF type vulnerabilities, SQL injections, XXE injections, and stuff like that. They're quite high impact vulnerabilities and stuff that I've personally made money from. And I model a lot of the labs based on vulnerabilities that I found and gotten paid for myself. So if you just want to advance your bug bounty career with more practical type of things, it's good that you're watching these videos as well. But this is kind of more theory side, and you want to really get the more practical side of it as well. Apart from that, I also have a free lab in the description, so you can check that out as well. Anyways, we'll move on to the next report, which is in Acronis. So the next vulnerability is in Acronis, and Acronis is like this cybersecurity dashboard management system for companies like SaaS to basically manage their cybersecurity needs. That's what we'll say. It's a bit complicated, whatever they do. And the vulnerability type is a quite rarely seen CSS injection, which is very interesting. That's a style injection, basically. Not seen very often. I haven't seen it yet anyway. So let's see what the attacker managed to achieve in this report. So this is very similar to the previous vulnerability where a path is basically concatenated without sanitization, but in this case it comes from a query parameter. So in order to fetch a static file, so a CSS file from a location on the server used a query parameter, which is interesting. That usually doesn't happen very often. So this query parameter basically determined what URL the server was going to fetch. So here, this was a theme, so presumably the user could select whichever one they wanted, and then the server was just going to fetch the corresponding theme in order to basically change the dark mode and stuff like that, right? But they forgot to sanitize it, right? So I imagine they just directly concatenated it onto the path parameter here, and that obviously is a no-no because the browser is going to normalize that URL. So whenever the attacker put down a path traversal string, the browser normalized it and the attacker was able to reach unintended endpoints. As you can see here, they were able to reach all the way to the root of the website. But because this is a GET request with fetching of a static file, that means that we will not have any authorization tokens or cookies appended to our request, which is unfortunate because whenever servers fetch static files, they don't include credentials. We also don't have any post requests, so it doesn't seem like there's a lot of impact to this vulnerability. We can kind of just make a GET request to some kind of an endpoint on the website, which we can do anyway from our website, so it's kind of useless. But the attacker actually did manage to show some kind of impact with this. So there's kind of this API thing here, and this I think looks like some kind of OAuth flow, but in this case it had a parameter here that accepted a URL, and the URL actually was an open redirect, so the website wasn't checking whether or not the domain was valid or not. It was just going to redirect the user there anyway. You can see that more here, where it just basically returned the location header here. And that is useful because if we can find an open redirect and we have a client-side path traversal, that means that we can actually make the user click on some kind of link in the website, and then it'll redirect them later to our website again. If we had like a post-based client-side path traversal where there was an authorization header inside of it, if we could find an open redirect, we could leak the authorization header because the server would send a post request and get redirected to our website. Then we could read the authorization header and log in as the user, like a full account takeover. So if this was a post-based client-side path traversal and we had an open redirect, we would have a one-click account takeover, which would be phenomenal impact. In this case, it was a get-based client-side path traversal with no authorization header. So in this case, it wasn't possible. But if you find this in the future, who knows, maybe you'll have that nice little critical vulnerability there. But anyway, what the attacker was able to do instead is host their own style file, like CSS file, on their own website, and then make the server load that website onto the DOM. And what that basically allows you to do is control the style on the website. And that means that the attacker could load in whatever CSS they wanted onto the website. And that basically leads into more of like an XS leak attack, so a cross-site leak attack. I'll talk more about that in my previous episode, so I have a video on cross-site leaks. But in this case, the attacker was able to basically exfiltrate data using CSS properties. So I think they were able to exfiltrate stuff like the CSRF token. I think that's one of the things you can really do with this. And obviously, I think you could actually get the user to like click on a button and actually make it do something completely different. Obviously, it's like a phishing style attack as well. So if you've turned this into like a login page and you were on the same website, a user might place their credentials and then they might get sent to a completely different website. So that's the main thing here that you can do with the style injection. Also key logging apparently, which is interesting. You can log keys. So that's actually a very useful vulnerability as well. Yeah, so that's kind of this style injection type vulnerability. I think the attacker got about $1,000 for this. Don't know how much Acronis takes actually anymore. They got, for a medium, about $2,000. Not too bad actually, not too bad. Fair enough. Yeah, not too bad. $2,000 for a style injection. Very interesting. First time I've seen a vulnerability like this. I think first time I've covered it on Hacktivity Explained. That's interesting. And yeah, the fix for this was obviously just to sanitize the path parameter here. Now, instead of URL decoding it, the website actually just left it as this percentage .2f, and then basically the path traversal was no longer possible, which is very good. Yeah, so an interesting type of escalation there with the CSS injection. So if you do find a path traversal that basically leads to loading in a static file, a JavaScript file would be ideal because that would basically mean you have an instant cross-site scripting vulnerability. That would be great. A CSS file is also okay, although a bit harder to exploit because you need to do like cross-site leak type attacks, which is a bit more difficult and harder to show impact on. But yeah, definitely something we can learn from this. A kind of at first innocent looking vulnerability, but turned into a pretty good payout by the hunter. Yeah, so I hope you enjoyed this Hacktivity Explained video just as much as I did. I'm going to definitely be looking for more client-side path traversals as time goes on. So do expect more content, maybe some more advanced techniques on how to look for client-side path traversals. And yeah, if you did enjoy this video, then you'll definitely enjoy my previous video on Hacktivity Explained, the one where I cover, oh yeah, server-side request forgery vulnerabilities, yes. Server-side request forgery vulnerabilities on Google AppSheet and something else that I can't remember. So yeah, You can go watch that episode. I'm sure you'll like it as well. And anyways, that's it from me. Thanks for watching and happy hunting.